Once all the data have been clipped and reclassified, in other words, and converted, so in other words, they're ready for analysis, we can start with whatever analysis we need to do. In this case, we're using the example of an agricultural suitability analysis. We want to see which areas are more suitable for some type of agriculture than others. Okay, so we're going to look at two approaches to this. The first one that we're going to use is an overlay analysis. You go to Arc Toolbox, you'll see there's a spatial analysis tools toolbar. So just open that one, open spatial analysis toolbars, open overlay, and then there's a weighted overlay tool. So you can double click that. So it tells us weighted overlay overlays several rasters using a common measurement scale and weights each according to its importance. So to start off, we need to add our 3 layers. So you can do that by simply, oh no, I thought you could drag it. It doesn't allow it. So you need to click on add and then click on your first layer, reclass rain. We're going to use the value field. The next layer will be the slope, again the value field, and then the last one will be the clay content, and again the value field that we reclassified in the previous video. Alright, so now what we need to do is we need to ensure that the field, so that's the value field values that we reclassified, is the same for what the tool will use in terms of the scale value. Okay, now the scale value, you'll see we've got a number of options. It asks you what's the evaluation scale that you would like to use. 1 to 9, 1 to 5, 1 to 3. So if we use 1 to 9, you'll see we get an option of something can be very bad or very good and everything in between. We said we're going to use a scale of 1 to 5. Okay, so I need to select 1 to 5 here, and then I need to ensure that my values are the same as in my value field, the scale value that the tool will use. Remember 0, we said, is a no data value. 1 will stay 1, 2 will stay 2, that one should become a 3, that one should be a 4, and that one there should be a 5. And then the 1, 2 is fine, 3, that should be a 3, and that one should be a 5 again. And then the last 0 again is a no data value, 2 will be a 2, and 4 is the 4. Okay, now you can see the only remaining field that we need to have a look at is the percentage influence. At this stage it states that rainfall has a 100% influence and the other two 0. So in other words, if I do the overlay, combine the 3 layers, only rainfall will be used because those 2 won't be considered because they are 0. So you've got an option to say set equal influence, and what you can see happened here, we've got 2 33s and 1 34. That's because the total should be exactly 100. Okay, so this should could have been 33.4, 33.3, 33.3. That would have been closer, but it does not consider the decimals here. Okay. But nonetheless, you should determine what the percentage influence should be. Usually we make use of what we refer to as expert opinion here. So depending on what we're working with, say we're working with maize, the expert might say, okay, considering these 3 criteria, or let's say the slope, the expert might say is important but not that important, so it should only be considered as 20% of the total, while rain, that's very important, so that could be, we've got a remainder of 80%, so we could say that should be, let's say, a 45%, so now we're at a total of 65, and we can say the remainder of that can be the clay, which is 35%. Okay, so this should be determined by the experts for the specific analysis. So there's no rule here as to what the influence should be. That will depend on the questions that's being asked. Okay, so for this exercise, let's set it to 45, 20, and 35% influence. In other words, rainfall will be considered more important than the slope of an area. And then finally, we need to specify our output location again. Weighted result. And then we're going to say OK. And the tool is executed, and a result is generated. So you can turn off the original datasets, And what we see here, if we zoom into this one, zoom to layer, is our suitability analysis. Now the areas in dark green, the 5, those are the areas that's, in terms of our criteria, the most suitable for agricultural production that we're looking at here. And the areas in the reddish colors are least suitable. The 3s, they're moderate. So the greens will be the areas to focus attention on. So that's an example of a weighted overlay. Now, as you change the weights between these 3 different layers, the result will start to vary. So you can do analysis with different weightings and then compare them to see which are the areas that almost always come up as important for whatever it is you're looking at, highly suitable, so for maize production in the province. Alright, so that's the one way in which we can combine these 3 layers. The other way is a simpler way, and it's called a raster calculator. And that's where we can do different types of calculations with our data, and it gives you a bit of more freedom to analyze your data. So we're going to have a look at that one next. So the raster calculator is also in your toolbox. I'm just going to search for calculator, and there you can see there's a tool called raster calculator. So I'm going to open the raster calculator, and it opens what looks like a basic calculator. Alright, you got a number of the basics here, and then you got a number of other mathematical functions that you could use as well. So what we're going to do in this raster calculator exercise is a simple we're just going to combine these 3 layers again. So we're going to say reclass rain. Now remember, what's going to happen if you run a raster calculator, it's going to use the value field. Alright, so that's why it's important to reclassify the values, because it's going to use, can't use that, it's just going to use my values when it's doing the analysis. So I'm going to say reclass rain plus reclass slope plus reclass clay. Just want to see what happened here. Okay, there it's gone. So we're gonna sum these 3. I'm gonna put a bracket there and a bracket there, and then I'm gonna say divide the result by 3, because I've got 3 input layers. I still want to see more or less out of 5 what the results are, and I can call it raster calc output. So you can see it's a simple mathematical equation that you're going to write using these functions here. I'm going to say OK. And here we can see a new result is added. So let's try to display it the same, more or less the same as our weighted overlay result. Let's just use the unique colors. I think it's that color scheme that was used. Yeah. Okay, so let's just make 0. I'll change it now. Make the 0 no color. And if we compare the two, well, what you can see here is more or less the same results comes out. So that's just a bit of a lighter color. Let's just try to make it more or less the same. Something more along the lines of that. The 2 maybe be a bit darker, but anyway, semantics now. Alright, so just for comparison's sake, we can see there's small differences here, but more or less the same areas that's identified as high potential, but a different approach. We did not use weightings now, we just combined the values with one another, excluded the weightings, and got a result. So there's different ways to do overlay analysis in raster. One way is not right, another one wrong. It depends on the question you're asking and the expert knowledge that you have to apply to this question. In some cases, a weighted analysis is better because you need to consider the weights of the data sets. Other times we can just use a simple overlay as the one I did with the raster calculator. Alright, so the raster calculator can also be used for other purposes. It's really quite a handy tool. So let's just open that raster calculator again. So for instance, I want to have a look at slope. and I'm only interested in the areas where we have a slope of 15 to 25%. In other words, a value of 2. I can ask raster calculator to have a look at slope and show me which areas have a value of 2. And the raster calculator will work through the dataset, look at all the different cells, and only select the ones basically that's got a value of 2 and may give them a value of 1, and the rest make it a 0. So now I have a new raster layer that I can use. So for instance, for another overlay, I'm only interested in those areas, or I'm interested in raster calculator open again. I'm interested in, let's say, this slope example again. Let's remove this one. Going to use slope again. I'm interested in everything that's let's say 25% or more in terms of slope. So everything smaller than 2, so value 1 and 2, everything smaller or equal to 2. So I'm going to say slope smaller or equal to 2, so it's going to work through that slope layer again, and only select everything that's a value of 2 or smaller and make that a 1 in my output, and I can say it's more or less the same. Okay, so that's a handy way in which you can use the raster calculator, and you can use it basically for any type of expression that you can build using all the different functions that's available here. So it's a very powerful tool if you know how to use it, and you can do quite nice modeling and analysis with this. In your honors here, you will look at more advanced ways to use this, and to use this also in a combination with a model builder, where you can build advanced models for analysis and modeling purposes. But for now, we're only going to stick with the weighted overlay and a simple raster calculator. In the next video, we will have a look at another set of analysis tools, the interpolation tool, and how to create them using interpolation, and then we're going to have a look at some other tools such as slope, aspect tool, shade, and view shed as well.